Welcome back. Before we get started, I'd like to remind you one last time that labs for this course meet at a specific time, and you should go to eServices and make sure that you know your section number and what time your lab meets. We've also put up a lab schedule onto Canvas, so if you know your section number, then you can see the name of your TA, and hopefully soon there'll be some Zoom links up so you can go there and then join your lab when the appropriate time comes. Alright, so in our last lecture, we introduced the concept of displacement, where displacement is the vector value of the change in position. That it is a vector means that the displacement has a direction associated with it. So remember, moving to the right is a positive change in the displacement, and moving to the left is a negative change in the displacement. The number that is given by the displacement is telling you the change in position. So if the displacement increases, that just means you're moving to the right, and if the displacement decreases, you're moving to the left. When we are looking at something that is moving up and down, then up is positive and down is negative. The reason we are so focused on displacement is that we would like to analyze motion, and in order to precisely define where an object is, we need the displacement. So if we know the initial position and then the displacement, then we know where it is now. The distance, so how far the object has moved in any direction, does not really tell us where the object is. If we drove 10 miles, but we don't know the direction that we traveled, we could have just driven around in a circle and we're back where we started. That 10 miles doesn't tell us where we are. So, right being positive and left being negative also applies to velocity. When we talk about a positive velocity, it means that our object is moving to the right and or it's moving up. If the velocity is negative, then the object is moving to the left or it is moving down. So a negative velocity is not slower, it just means that it's moving to the left. On the other hand, speed is the scalar value, so it is the number on the speedometer as you drive, and it doesn't have a direction associated with it. So the speed is something that's always positive. The velocity, on the other hand, can be positive or it can be negative. And then the last concept that we brought up last time is acceleration here. So acceleration is the change in the velocity. So the acceleration is the change in velocity divided by time. That means that if the acceleration is positive, then the velocity is changing to the right, or the motion is changing to the right. This is where this starts to trip people up. So we have a question here. What happens if the acceleration and velocity are in the same direction, and what happens if they're in the opposite direction? If your acceleration is positive and your velocity is positive, so then they are both in the same direction, then the object speeds up, the velocity becomes more positive. And if the velocity is negative and the acceleration is positive, that means the object slows down. The object is moving to the left, the acceleration is to the right, so that means that it's going to slow down. The positive acceleration means that the velocity becomes more positive, so the velocity becomes a smaller negative number. This is what trips people up. If the velocity and acceleration is in the same direction, then the object speeds up, and if the velocity and acceleration are in the opposite direction, then the object slows down. So it doesn't matter whether it's positive or negative for the acceleration, it matters whether it's positive or negative relative to the velocity. So an example of the velocity and acceleration being in the same direction is when a car is moving to the left, so its velocity is negative, and its acceleration is to the left, so the velocity is becoming more negative. This means that the speed is increasing, despite the fact that the acceleration is negative. This is what trips people up, right? You hear negative acceleration, but that just means it's an acceleration to the left. That's it. So if you're moving to the left and you're accelerating to the left, then you are speeding up. And if you're moving to the right and you have a negative acceleration, then that means you're slowing down. So the same thing happens when you are moving up and down. Up is positive and down is negative, so gravity is accelerating down, so a falling object has a negative acceleration. It doesn't matter whether you've thrown the ball, whether it's moving up in the air, or whether it's moving down. Either way, the acceleration from gravity is negative. Okay, so now we have a short problem to do. We have jogged to the right 400 meters in 200 seconds, and then we jog back to the left 100 meters in 25 seconds. So we want to know what is our average velocity and what is our average speed. So in the first part, we run 400 meters to the right in 200 seconds. So the average velocity in that first portion is 400 meters divided by 200 seconds, which is 2 meters per second. Since we are moving to the right, it's positive. Next, we run back 100 meters to the left in 25 seconds. So the velocity in the second part of the run is negative 4 meters per second, right? The displacement is negative 100 to the left, divided by 25 seconds, and we get negative 4 meters per second. So our displacement there is 100 meters to the left, so it's negative 100. Okay, so notice the fact that the velocity in the second half of the run is negative does not mean that we've slowed down, right? We've actually picked up the pace. It's just that we're running to the left now. But we want to ask the question, and so that is, what is the average velocity for the full run? So to do that, we divide the total displacement by the time. So we ran 400 meters to the right, and then minus 100 meters, so to the left. So the total displacement is 300 meters. And then we divide that by 225 seconds, which is the total time, 200 seconds plus 25 seconds. So that gives us 1.3 meters per second. So the net displacement was 300 meters to the right, and we did it in 225 seconds, so the average velocity is less than the speed. To find the speed, we divide the distance traveled by the time, so the total distance is 400 meters plus 100 meters, right? So 500 meters total, and then we divide that by the 225 seconds, and we get about 2.2 meters per second. So that's the average of how fast we were going since we covered 500 meters in 225 seconds. Notice that 500 meters doesn't tell us where we are. We need to know the displacement in order to precisely define where we are. So yeah, so you can see this is where some confusion can occur in comparing speed and velocity. Average velocity only cares about the displacement, so how far you've traveled from where you started, and then you divide by the time. So here's another example. We start at our home and we drive 60 miles on a straight road in 1 hour. Then we drive back home in 2 hours. So what is the average velocity and what is the average speed? Well, for the average velocity, it's the displacement over time, and the displacement is 0, right? We're back where we started, so that means the displacement is 0 miles. We divide that by 3 hours, so our average velocity here is 0 miles per hour. On the other hand, for average speed, in this case we traveled 60 miles out and 60 miles back, so we traveled a total of 120 miles, and we did it in 3 hours, so our average speed here is 120 divided by 3, so it's 40 miles per hour. So velocity depends on the displacement, so how far you have moved from where you started, and the path that you took there doesn't matter. So this is useful because it tells us exactly where we are. If we know the displacement, we know exactly where we are. While on the other hand, speed is how fast you are traveling, averaged over the whole time. Okay, so you have some questions to answer, so good luck, and next we'll look at constant acceleration.